In this lecture, we're going to go over the chi-square analysis. I'll be using the examples from the Dimitrov text, Quantitative Research and Education, in order to help you understand the computations and where the numbers are coming from. It might be easier to examine the chi-square test in the context of the other tests that we've looked at. Recall that the independent t-test evaluates differences between a continuous variable across a categorical variable. The example that I give is that we're looking at mean differences between depression scores on the BDI-2. Now the scores on the BDI-2 is a continuous dependent variable, but the two groups, males and females, would be a discrete independent variable. Now a Pearson R is a test that we use to evaluate the relationship between two continuous variables. In this case, they'd be two scores, such as the relationship between scores on a depression scale and the scores on a disordered eating scale. So whereas an independent t-test looks at differences between two scores based on a continuous variable and a discrete variable, and a Pearson R looks at the relationship between two scores for two continuous variables, a chi-square is looking at just categorical variables, such as maybe ethnicity and career type. What's the relationship between a person's ethnicity and the career type that they choose? We're going to talk about two different types of chi-square tests for this introductory lecture. The first is called the chi-square Goodnessoffit test, and it's used to determine if what we have observed is significantly different from what we expected. For example, let's say I have a group of high school students who are choosing between attending a public university, a private university, or a community college. What would be the percentage that I would expect for those students to attend one, the first, the second, or the third college, and how many actually do attend, say, a private versus a public versus a community college. Now, the second type of test that we're going to look at is called a chi-square test for association, and it looks at the relationship between two categorical variables. In this way, it's kind of similar to the Pearson R, which looked at the relationship between two continuous variables. So we'll talk about examples in each of these. We're going to go over the chi-square Goodnessoffit test, and I'm going to show you how this value is calculated so that you understand where the numbers are coming from. But for each of the examples that we go over in this lecture, I'll also have an accompanying tutorial that shows how to do this in SPSS. But in the meantime, let's look at the calculations for this. In the Goodnessoffit test, recall that we want to see if there's differences between what was observed versus what was expected. So let's say I have 27 people fill out a survey question. And the survey question has three options. For example, the 27 students I mentioned who have to choose between attending a community college, a public four-year institution, or a private university. If they were just to randomly pick one of the three, perhaps there'd be an equal chance of picking option 1, option 2, or option 3. So in this case, if I have 27 individuals or 27 students, the expectation is that this would be a total equal choice, and that 9 people could possibly choose a public university, 9 people could choose a private university, and 9 people could choose a community college. And what's observed is that when I actually collected the data, 12 people chose option 1, 6 chose option 2, and 9 chose option 3. So the question is was there a significant difference between what we observed with these choices versus what was expected? And in order to compute that, you simply take the observed value minus the expected value, you square it, and you divide it by what was expected for each option. Okay, I know that formula was a mouthful, so let's go over that again. It's the observed value minus the expected value squared, and then we divide it by what was expected. And so you can see in this example where the numbers are coming from. There was an equal expectation that students would choose option 1, option 2, or option 3. So it's 9 all the way across. Now notice the 12 was what was observed. The 9 was what was expected. So we subtract 9 from 12, we square the value and divide it by what was expected, the 9 again. And then the same thing. We take the 6, the observed value, minus the 9, the expected value. We square it, divide by 9, and then we do the same thing for 9 minus 9 squared, and then divide by 9. And you can see that when we add up those values, we get 2.0. And then you can see at the bottom of this page what that would look like in SPSS, and that P would be greater than 0.05. And so we'd say there's really no significant difference between what we observed and what we expected. And what that means is although there were some differences, they weren't significant, they weren't meaningful. They could have happened by chance. There's not a particular purpose behind it. So these differences did not occur outside the realm of chance. What we have observed and what we are expected are relatively the same. Okay. So what happens in a Goodnessoffit test if what we expect is not equal all the way across? For example, let's say I enroll 80 students in a class, and from those 80 students, I'm keeping track of their identified ethnicity. I may know from the population I'm working with that I expect 50% of the people I enroll to be Caucasian, 20% to be African American, 15% to be Hispanic, 5% to be Asian, and 10% to be of another ethnicity than what I've just identified. So if I know that that's the population I'm drawing from, I can use those as the expected frequency. So if I've got 80 folks, I preset that 40 of those should be Caucasian, 16 should be African American as part of that 20%, 15% should be Hispanic, so that's 12 out of 80, 4 should be Asian, and that's 5% out of 80, and then the others, the 10%, will be 8. You can now see that this is calculated the same way we did the first example, except my expected values are different. So again, 32 minus 40 is negative 8, squared is 64, divide by what was expected, 40, and we get a value of 1.6. 18 minus 16 is 2, squared is 4, divided by what was expected, 16, and you get a value of 0.25. And we just go ahead and we do this for all of our values, and we end up summing them and getting a value of 12.558. So just take the observed minus the expected, square it, and divide by what was expected. Now we're going to go over a chi-square test of association. Recall that a chi-square test of association looks at the relationship between two categorical variables. In this case, I want to look at to see if there's a relationship between ethnicity and employment category. And I have 3 employment categories in this example: clerical, custodial, and manager. And we're looking at whether somebody's identifies as minority status or no minority status. So I have an employment category and a minority classification, and I want to know if there's a relationship between these two. And so you can see in the table on the right, marked 12.3, you can see the observed values for each of the employment categories based on minority status. So a non-minority, 276 went into clerical, 14 went into custodial, and 80 went into manager. Now look at the minority status. There were only 4 individuals who went into manager. 13 went into custodial, and 87 went into clerical. And what we can do is we can sum the rows and the columns. For example, the clerical category for both minority and non-minority candidates was 363 folks. For the custodial, there were 27, and for the manager, there were 84. When you look at just the non-minorities status, that's 370, and the individuals who are minority status, that's 104. So my total sample size is 474. That's either the total of my rows or the total of my columns. So I hope those numbers are making sense. And it's very similar in terms of how we calculate the chi-square. And you can see in this table 12.4, the calculation is a little more complicated. I call it chi-square hell. And what I want you to notice is that the observed value is already given to you. But how do you get that expected value? Well, the expected value is going to be the row, the appropriate row, times the appropriate column, divided by the total sample size. And I'll show you how we calculate those values in the subsequent slides. But notice, once you calculate your expected value, it's rather easy. Once you get your expected frequency, it's just the observation minus the expected value, the observed minus the expected, square it, divide by what's expected. So that's where those values are coming from. Take, for example, the expected frequency from the first row, no minority clerical. We have an expected value of 283.35. Well, how do we get that? Well, we took the value 370 from row 1, multiplied it by its corresponding value of the column 1, so row 1 times column 1, divided by the total sample size of 474, and we got the value of 283.35. Okay, so here's the expected frequency for the non-minority custodial group. So notice that we have an observed value of 14. And so, again, we take the corresponding row value times the corresponding column value, so 370 times 27. Multiply that, divide by 474, and we get 21.076. So notice, we can then take 14 minus 21.076. That's the observed minus expected value, and you get minus 7.076. Square the value, 50.07, and then you can get the chi-square value, observed minus expected squared, divided by what's expected, and you get 2.376. So you can kind of see where those values in that second to last column are coming from. Now you see the third corresponding value. The observed value is 80. All right, and the row again is 370, but the column now is 84. So 370 times 84 divided by the total sample size of 474 is 65.57. And that, once again, you can subtract that value from the observed value of 80 and you get 14.43. Square it and divide it by the expected value again. And you get your chi-square value, or not your chi-square value, but your value that will be summed to get your chi-square. Now let's look at the second row values for minority status. Here you're going to do the same process again, but you're going to use row 2 values. So 104 times column 1, 363, divided by 474 is going to give you 79.65. And then again here we can use the row 2 value again and the column 2 value. So every possible combination gets done here. 104 times 27, and then divide that by 474 equals 5.92. And then that's subtracted from 13, you get 7.076, and then you can get your same values that we've done before. Okay, and for the final count, we do the second row value of 104 times the column 3 value of 84 and divide that by 474 and we get 18.43. And again, 4, the observed value minus the expected value of 18.43 is 14.43, and we can square that and then divide it by the expected value of 18.43, and we have our value of 11.298 or 11.3 if you just round it to decimals. And then you add all those values up in that second to last column and you get your chi-square statistic. That chi-square statistic can get compared to a critical value. In this case, it's the number of groups minus 1, but we have 2 groups. So how many levels are in employment category? I see clerical, custodial, and manager. So 3 levels, 3 minus 1 is 2, times the number of levels minus 1 in minority classification. So 2 minus 1 is 1. So 3 minus 1 is 2, times 2 minus 1 is 1, 2 times 1 is 2. So we're going to compare this to a chi-square with the degrees of freedom of 2, which is 5.99. Remember your golden rule, observed value is greater than the critical value, so we have statistical significance. And then finally, we can see where that we can have a kind of an effect size for each of the categorical levels. We can see what's contributing to that statistical significance by computing the standardized residual. And that formula is here at the bottom corner. It's just the observed minus the expected divided by the square root of the expected. And so we can do that for each value. For example, negative 7.354 divided by 283.35 equals negative 0.44. So the square root of negative 283.35, I should say, is negative 0.44. Again, 14 minus 21.076 divided by the square root of 21.076 is negative 1.54. Now, anytime that you have a value greater than 2, a positive or negative, so an absolute value of 2, so that's minority custodial and minority manager, those are the 2 values that seem to be contributing the most to the statistically significant finding here. So that's how you would interpret that, as any value greater than 2. That concludes our hand calculation. I hope you found this lecture helpful, and now please proceed to look at the tutorials on how to do this in SPSS.